We are going to continue. We were talking about various property of vectors the other day, okay? So we defined the last thing that we did, we defined the dot product on the vectors. Okay, that will help us to connect it to the norm. And the last example that we did, we find a formula for angle between the two vectors. Okay, the cosine of the data, x dot y over norm x norm y. There are a couple of places that we are going to use this one. Okay, and we give you an example to find the angles. The part that we're going to be interested in is the case that these two vectors are, if the angle is going to be 90 degrees, so in that case, the vectors are going to be perpendicular or orthogonal. If the angle happens to be pi, in that case, the vectors are going to be parallel. So I'm going to give you official definitions or make a note of this one because we need it for for the rest of the course. Okay, so this is going to be just give you a remark regarding this property. We use it quite a lot, okay, for the when we get to the function. Okay, the remark. The first part, we are going to introduce perpendicular. Okay, so the first one, what is going to be perpendicular vector? Okay, perpendicular vectors. Okay, perpendicular, and from time to time we use the expression orthogonal. Okay, that's it. It's two expressions that we're going to use, orthogonal vectors. So this is how we are going to define it. Two vectors are going to be perpendicular if the dot product is zero. We just talked about it the other day. So the vectors x and y are going to be perpendicular or orthogonal if x dot y is equal to the zero. Okay, so that would be easy to check. Okay, for this one, so that's going to be perpendicular. And the second one is parallel. So what is going to be parallel vectors? You know that the angle is going to be pi. When the angle is pi, we talked about it the other day. One of them is the scalar multiplier of the other one. So the vectors x and y are going to be called parallel if the angle between these two are going to be zero, or the angle is going to be pi. Almost, they're going to be the same. So there is going to be equivalent version that we're going to use. So that would be more popular. Equivalently is going to be used quickly today to get the definition of the equation of the plane and the equation of the line. So equivalently, this means one of them is the multiple of the other one. So equivalently, x and y are going to be parallel vectors. Okay, they're going to be parallel vectors if there is going to be a number, a constant, a number k such that x, for example, is equal to the k times y, or y is going to be equal to the x. Okay, so we are going to use both of them in this form. So two vectors can be orthogonal if they ask you to prove it. So we just find the x dot y. If it's 0, they are going to be perpendicular. For the parallel, you check to see if you can factor out, multiply one of them by number to get the other ones. So we usually give you one question on this quiz. Okay, any question? Let's check the way you are going to do it for us. So you have a set of problems in your assignment. Again, try to get one of them. For example, you'll be asked to determine whether the vector is going to be perpendicular or parallel, or whether the given vectors, okay, are going to be orthogonal. It's a more popular version for the term. Orthogonal, parallel, okay, or neither, or neither. Okay, so the first one, for example, is that x is given to x is a, b, c, and y is equal to the negative b, a, and 0. They are not parallel, as you can see. One is not a factor or multiple of the other ones. So we check to see if they are going to be perpendicular. Okay, find the dot product. So the solution is going to be check the dot product. It's going to be x dot y. Okay, you know that you multiply these, so it's going to be a times negative b plus b times a plus c times 0. So that gives me negative ab plus ba plus 0. And you know that these two would cancel out, so that gives you 0. That's it. So x dot y is equal to the 0. So this means they are perpendicular. It's the notation that we use from time to time. Okay, so x and y are going to be, so they are perpendicular or orthogonal. Okay, perpendicular case. Vectors. Okay, so that would be easy to check. Any question? Let's give you another one. So the other one is going to be, I'll go to the next page. Other one is this one. That's a number 2. For your number 2, the vectors are x is equal to the 1/2 of I minus 2/3 of j plus 3/4 of k. That is one of them. And the other one is y is equal to 3/4 of I minus j plus 9/8 of k. That is going to be the case. Okay, you check to see if they are parallel. Any suggestion? Can you see if one of them is a multiple of the other one? Means if you multiply one of them by a number, you get the second one. Yes, 3x equal to the 3/2 of the y. X, no, maybe the other way around. 3/2. Y equal to the, okay, y equal to 3/2 the x. Yes, Kelly, you're right. So this is it. Yes, that's it. So the solution is going to be, because this is, this is 1/2, this is 3/4. So if you find the 3/2 of x, multiply, you say this 1/2 to make it 3/4, we have to multiply by 3/2. So we just confirm it. It's going to be 3/2 times 1/2 I minus 2/3 j plus 3/4 of the k. So that would give us the result. So that gives it 3/4 of I minus these 2 and 2 would cancel out. Everything would be cancel out. That give you 1, 1 if you like, j and the 9/8 of k, which is equal to the, okay, which is equal to the y. So basically y equal to the 3/2 of x. So they are parallel. Okay. So x is parallel to the y. The notation that we're going to use from time to time. So we get the parallel vectors. Okay, so that's going to be the case 2. Any question? So I have another one, the case 3. Okay, we get case 3 is going to be this one. I have another case, yeah, let's do one more. Just x is equal to the 1/2 of I, okay, minus 2/3 of j and the 3/4 of k. And the second one is something like 12I plus 9k. You see that would be way out for the parallel because of these numbers that you have. And if you check the dot product is not equal to 0. Okay, just quickly give you the fact that the solution, they are not going to be parallel. If you check the x dot y, it's not going to be 0. We can check it quickly. So that gives us the 1/2 times 12. And that would be negative 2/3 times 0. And that's a 3/4 times 9. Okay, this would be 0, and that would be 6 is not equal to the 0. 27/4, not 0. And as you can see, one of them is not the scalar multiple of the other one. So the answer is going to be, in this case, neither. They're going to be, they're not parallel and they are not going to be perpendicular. Okay, so we are going to use it in a minute for some other purposes. But from time to time, you should be able to identify it. Okay, any question? Now, to get quickly to the application that we need, there are 2 other terms. And this and next one, we are not going to use it, but there are a couple of application in physics. So we just want to make sure you know the names. We call them directional. We talk about the angle between 2 vectors. Okay, if you find the angle between a vector and the standard one, remember the standard one, IJK, these angles would have a special name. The name is going to be direction angles, and those cosine formula with the direction cosines. Okay, we just have to mention it, but we are not going to use it directly. So just to finish the concept, we create that one too. Okay, you have some problem in your book, but you're not going to be questioning this. Okay, so let's finish these definitions. But there is one big one at the end, which is a projection. We need that one. Okay, so just to finish, but not going to be question on this. What is direction angles? Okay, direction angles and direction cosines. So I'm going to use some expression in physics or in mechanics. They use this. So the angles between a vector and a standard one is going to be called direction one. If you do it with the between the vector and I, it's an x direction. You know, you do it with j, it's going to be y direction. And if you do it with the k is going to be the z direction. So just name it. So the angles. Okay, the angles between a non-zero, of course. Non-zero vector like x and the vectors, the standard vectors. Vectors I, j, and k. Okay, these are going to be called the direction angles. The direction angles of x. Okay, direction angles of x, and the cosine of these angles, of course, called called direction cosines. And the cosine of those angles, cosines of those angles are called the direction angles, the direction cosine, direction cosine. Cosines of x. Okay, it can be found directly if you need it. It's easy to find, but if you like formula, I just find one of them for you so they can see it. Again, it's not a big deal, because you know that the cosine of the data is x dot y over norm x norm y. But if you like to make it as a formula, this is the option. So if x is going to be equal to the x1i plus remember x2j plus x3k, then you are going to find the expression that we use cosine of the alpha. This is going to be the direction angle between the vector x and I. So the formula, remember, x dot y is in this case going to be x dot I, and this is going to be the norm x times norm I. Of course, I is a unit vector, so the norm I is 1. Then x dot I, you can just multiply them together and you will see the result. You see x dot I, and this is going to be your x, and you know that the I is going to be, so if you multiply them together, so what's going to be the result? The result is going to be x1. X1 is a scalar, so the vector part will be multiplied together. And that's going to be x2. It's going to be I times j, or dot j. And that would be x3 and the I times k. And that would be the norm x times 1. But you know that they are I times I is just a unit vector. That's going to be 1. I and j are perpendicular to each other. That give you 0 dot product. I and k are perpendicular. That give you 0. Okay, so the first one is unit vector. You know that I times I would be norm I squared. Ij perpendicular, Ik perpendicular. So the result would be simply on the top, you are going to get the x1, and on the bottom we get norm x. See if you like formulas. So the cosine of the alpha is going to be x1 over norm x. Okay, this is going to be, they call it alpha. So they call it cosine. This is going to be cosine in the direction of I. Similarly, you can have other directions. They usually go with the beta or the other, or the y. We can do in the direction of the j. So the top would be x2 over norm x. Okay, this is going to be in the direction of j, and they usually go with the gamma, which is going to be x3 over norm x in the direction of k. Okay, if you like formulas, but otherwise, you know, even if you don't the formula, you can find it when the situation, you know, would be asked for it. But they love the fact that if you just find the square of these 3, the result would be 1. So you have to know it. See, you have some problems in your book. They ask you to find it and confirm it. So if you find the cosine square of the alpha plus cosine square of the beta plus cosine square of the gamma, that give you what? x1 squared, x1 squared, norm x squared, x2 squared, norm x squared, x3 squared, norm x squared. You know that if you add the top together, the result would be norm x squared. So the final answer would be 1. Okay, so if you like, it's x1 squared, x2 squared, x3 squared, and that's a norm x squared. So the top would be norm x squared. And this is the norm x squared. So the result is 1. Okay, so that's a popular result, that the sum of the square of the direction cosines is always equal to 1. Okay, just for your information. So one vector would be given and they ask you to find this, but we are not going to use it. Okay. Yes, I unit vector in the x direction, that's it. You know that the ijk are going to be a standard vectors that we are going to have. I would be a standard vector in direction of the x, so that's going to be the case. But the vector would be given to you, then you find the direction for that vector. So that's going to be the case. So that would be the cosine. You know, that's the cosine direction of the vector x, the cosine direction of the vector x in the direction of the I, direction of the j, direction of the k. Okay, just give me one example to see how you do it with your assignments. With your book, they like it. There are, as I told you, some application in physics with this type of ideas. So just you better do one of those problems just to remember the application of this formula. But we are not going to use it quite a lot. So this is the type of question that you see. Find the direction cosines, the direction cosines of the vector. And this is the vector. X equal to the 2i minus 4j plus 4k. It's the only possibility that you know that can to get these numbers. They ask for the dot product of the x and the I. Okay, that's it. You see, if you get the dot product, the way I did it over here, we just do it as you know that get the dot product of the x and the I. X is going to be what? So the component, the first component of the x is x1, okay, and the way I did it is like the algebraic part, if you like. You know, I just multiply them together because you can remember this is it. Let me explain it here. Remember the dot product. So this is the way I used it. Yes, explain it. You see, I want to do the x dot I. So what is x? Is x1i plus x2j plus x3k dot I. Remember that product is you can use a distribution distributed inside. So this is the scalar, this is the vector. It's going to be x1. Okay, it's going to be x1i if you like dot I. The first one, the second one x2j dot I, the third one x3k dot I. Okay, and you know that this is equal to 1, and this is equal to the 0, and this is 0. So the result would be just x1. Okay, because you know that the dot product is you can use the distribution law for these numbers. Okay, so let's go back, and over here, you know, just a standard, just a formula substitution to get the result solution. That's it. So your vector is what? It's 2, -4, and 4. So you need the norm of the x. Norm of x is going to be the square root of 2 squared, -4 squared, and 4 squared. So the 2 squared would be 4, 16, 16, 32, 36. So the norm is 6. Now we can find the directional vector by the formulas. So the cosine of the alpha, remember, is x1 over norm x. So the x1 is 2, the norm is 6, so that gives you 1/3. Okay, so the cosine of the alpha is 1/3. They ask only for the cosine, but you can use your calculator if you like to find the alpha. So alpha would be cosine inverse of 1/3. With your calculator, you get 71 degrees. But they didn't ask for it, you know, but in your problem, in your book, they ask. Okay, question. We do the same thing for the cosine of the beta. This is going to be in the j direction. Sorry, that's x2. the norm x, x2 is a -4, so -4 over 6. So that gives a -2/3. So the cosine of beta in a j direction, -2/3. Again, they didn't ask for it, but you can use your calculator. Beta is 132 degrees. Okay, and the last one, cosine of the gamma is going to be x3 over the norm x. x3 is equal to 4. So that gives us a 4/6, which is the 2/3. So the cosine of the gamma is 2/3. But again, if you use your calculator, that's going to be 48 degrees. Okay, you can get the confirmation at the square of the sum of the squares to confirm that it is equal to 1. So cosine square of, you don't have to, but sometimes they ask for it, or you can do it to make sure you get it right. So what you have, cosine of the alpha, you have 1/3, so it's going to be 1/9. Cosine of the beta is 2/3, that gives you 4/9. And the gamma is 4/3, that gives you 4/9 again. So the result is going to be 9/9, which is equal to 1. So this means you did all right. Okay, the result is true. So these are some small points, but it's going to be used from some, time to times to get it. Any question? So what else do we need to know to finish this section 1.1.3? Now, there is one concept of these, or one property of these vectors that are going to be used quite a lot in future. So we're going to discuss it. Is it supposed to be 1/9? This is -4/9. You square it. You see, you square all of this. So -2/3 squared, you get a 4/9. That would be positive 4/9. Okay. Because the numbers are here, but you have to square. You get the square of these numbers. Okay, any question? Now, pay attention to this last bit. That it's in your book, they talk about it previously, if you like, but I put it over here because this is where we're going to get it. Now, when we go on in this course from time to time, there is going to be at the beginning, when we get to the next sections, if you like, we have the concept of the distance. We are going to consider, we already consider distance between 2 points, then we are going to consider distance between a point and the plane, distance outside of the line, etc. For some other purposes. We need this idea. This idea is called projections of a vector. So see, if you have a vector and you consider the vector if you begin 2 vectors, if you like, then you can find the projection or the shadow of one vector to the other ones. That shadow is going to be called projection. So what is, you must know this one, okay? We're going to use it in different places toward the course, right through the end. So what is going to be the projections? You see, this is a situation we're going to have. If 2 vectors are given to you, okay, if you have 2 vectors, it's going to be vector A. And this is going to be the vector B. Okay, we have the vector A and the vector B. Now, if you find the shadow, you can think about as a shadow of the B over A, if you like. So this is going to be the case. See this portion over here. This portion over here, we refer to it as a projection, the image, if you like, the projection. the projection of B of the vector B onto the vector A. Okay, it's a very important concept. The other name for it, you can think about it, or the shadow, if you like, the shadow of the vector B. Okay, we get the B and we find the image or projection of the B over the A. Okay, that's going to be the, but kind of, yes, I call it a shadow to get this one here. Okay, so we get the B projected over here, you get the vertical line here, and the result. We have a special notation for it. Okay, it is denoted by, that's a notation, it's a standard notation that we're going to use. Project, that's it, projection of B onto A. Okay, so this is the way we're going to denote it. Projection of B onto A. And you will see, when it's given to you, or A here, or simply this is it. B on A. Okay, so the positions are important. You may have a projection of A on B. Okay, so make sure you know that which one is given to you to get these numbers. Okay, so what we would like to do, we would like to find it. We would like to find a formula in order to do it. So let's see how we're going to make. How we're going to find it. Okay, so let's get the relationship between that projection, which is going to be this bit, a segment. The relationship between this one and the vector A that we're going to have. As you can see, that projection is going to be along the vector A. So they are parallel to each other, if you like. Remember, if the angle is going to be 0 or pi, we call it parallel. So if this is going to be the parallel, so this is going to be a portion of the A. The portion of the A, as we talk about, this means it's going to be a multiple of A. Okay, so note that this is it. See, that projection is a part of A. So note that the projection of B onto A is part of the A, or it's parallel to the A. So it's going to be, okay, it's going to be equal to the multiple, K times A. Okay, K times A, where K is a number. Okay, it's going to be a scalar. Is a scalar. Okay, because they are parallel to each other. So what's that? It's a parallel to each other. So one of them is going to be a scalar multiple of the other one. So that gives us a better idea. And so in order to get the formula, we have to find finding this K, if you like, to be able to get the formula. Let's look at it from the other point of view. So this is, you can write the formula right away, but I wanted to find it. You see, if you consider it in this form again, so I have the A, this is going to be the A, and this is going to be the B that I considered. Then I get so this is going to be a kind of right triangle. Okay, so this portion is KA now. So what I do is, this is the right triangle. So I consider this angle in between is going to be data. Okay, so I want to put these together to find a K. Get the numbers. I'm going to find the K in a minute. Okay, so what is going to be the case? Remember, what I can do is I can find the cosine of the data. from the formula of the angles between two vectors. So what is going to be this one? Cosine of the data. Remember the angle was x dot y over norm x norm y. The formula for the angle between two. So it's going to be the vectors that I have are going to be just simply a and the b. So this is going to be a dot b divided by the norm of the a times the norm of the b. Okay, I get this one from, you see, data is the angle between vectors a and b. This is one formula. On the other hand, I can also use also. So I want to relate it to the KA. So I consider this right triangle. Okay, the right triangle, and I find the cosine again from this angle. So cosine of data, cosine is going to be what? It's a right triangle. The cosine is going to be adjacent side. Adjacent side is KA. Okay, it's going to be KA divided by what? Divided by the hypotenuse, which is going to be B. But I'm just talking about the length of this. So this is going to be the norm of the KA, and this is going to be the norm of the B. Okay, so I just use the definition of the cosine to get this number. And so I continue on the top. Remember, K is the number, so I can put it out. Use the absolute value of K if you like. Then this is going to be the norm of the A, and this is going to be the norm of the B. Okay, there you are. We're almost done. So let these two cosine to be equal to each other. Okay, K is going to be positive. So I can check this one to be, it doesn't matter really, it's going to be K times the norm of the A over the norm of the B. So connect them together, both of them to be equal to each other. So from these two, I'm going to have A dot B divided by the norm of the A times the norm of the B. And over here, I have the K, norm of the A, and this is going to be norm of the B. Now I solve for K. These two would cancel out. Okay, so if I solve for K, this is going to be A dot B equal to the K norm of the A squared. And eventually I got the K. So K is equal to A dot B over the norm of the A squared. I just, different way to express it, but I just wanted to give you kind of a proof if you like. So eventually I give you a formula. So the projection of B onto A is equal to, remember it was K times A. So now it's going to be what? It's going to be A dot B over the norm of the A squared A. Remember this quotient, A dot B is a number, norm A squared is a number, so these are going to be a scalar. It's going to be the scalar, and this is how you get it. Remember, it was a part of the A, but this part of the A dot B over norm of the A squared over A. You have to memorize this one and a couple of places that we're going to use it, and we get some nice formula from time to time. Okay, so this is going to be, where did I get the equation in the blue again? This one, I just use it the definition of a cosine in a right triangle. Okay, definition of a cosine. The cosine is the adjacent. Okay, So, it's nice to know the relationship that we're going to have. You know that we use this in linear algebra too quite a lot, and that is just the beginning of a procedure that we call it Gram-Schmidt procedure in order to provide orthogonal projections. So it's a very popular term. In this course, not much. We use it for some purposes to give us a short proofs, but it's going to be used quite a lot. Okay, so make sure you know it and don't miss the formula. We give one question of this one on this common quiz. So remember, it's some people they confuse about this part. You see, when it's a projection of the B onto A, it's part of A. So A is here. It's a part of A. So A is here. Then you need only these numbers, the scalar part, to be able to do it. So A. Okay. So let's give one example. So remember this, and I'm going to use it in a couple of nice places. Even when we get to the top, we are going to use it later on in a spherical coordinate. There are cases that we're going to use this one. There is something we call it change of variables for integrations. Again, we use this one. Okay, so example, I give you one. So we want to find the projection. And you can bring any formula to the test. We talk about it. It's a one page, two-sided, but all of just formulas. And when you go to the APC, I've already given them the instruction that you can have one page formula sheet. Okay, so you don't have to memorize the formulas. So find the projection. Find the projection of this vector. The vector V is 2i plus j minus 3k onto what? Onto this vector, the vector u, which is equal to the negative I plus j plus k. That's it. Okay, it's a v onto u. Just write the formula and get it done. Okay, what do you want? Let's just go back. Somebody get it. This is the last one that we didn't have. Yes, the formula sheet for every exam and the final. You can use it. Okay. I will post these lecture notes as well. Okay, are you done? We're going to that example. Okay, so that's it. So make sure that get the formula all right. This is going to be the solution. So basically you have the, this is the case that you have. So you have the V here and projected to the U. So this is the part. So your formula is going to be, you would like to find the projection of V onto U. We talk about it. This means this is going to be part of U. So U is here. Then you get the norm of U squared. And on the top, it's going to be U dot V. It's the way you get the formula. So it's a part of U. Part of U. And then you are going to provide those information for us. So you need to find the dot product and the norm of the U squared. Okay, so let's go for it. So this is it. The vector U is negative 1, 1, 1. The vector V is 2, 1, negative 3. Go and find this quantity that you need. You need the norm of the U squared. So it's going to be negative 1 squared, 1 squared, and the 1 squared. So 1 plus 1 plus 1, which is 3. So it's a norm of the u squared. Okay, you need u dot v. U dot v. This is it. The dot product. -1 times 2 plus 1 times 1 plus 1 times -3. So that gives us a -2 plus 1 minus 3, which is going to be -5 plus 1. We get a -4. -4. Okay, so we need, we have everything we need. So we go to the formula and we substitute. So the projection of V into U is going to be equal to, we got this quotient. U dot V is a -4. Norm of the U square is equal to 3. And the U. So it's going to be -4/3 times the vector, is a -I plus a J plus K. You just distribute it. Okay, that's a V onto U. You have to multiply this one inside. It's going to be 4/3 I minus 4/3 J minus 4/3 K. So that gives you the final answer. Okay, again, it would be fine, but make sure you get the correct, correct formula to get the results. Okay, so from time to time we get back to this one. Okay, so that's why we need it. We can't do anything else at the moment, but we do quite a lot in future to get these numbers. Okay, any question? So we're done with the 11.3. So we're done with the dot product, which is, help us to be able, help us to be able to define these, especially these terms. The vectors could be orthogonal, parallel. There are a couple of nice problems regarding the norm of these orthogonal vectors. We have it on the practice quiz, and we can check it tomorrow. And to get to it, now we need one more concept, one mild one, but very important for the notion of the function in future. Okay, so no, the form, the way you write the final answer is not important, but if the vectors are given to you in IJK form, so you have to give the result in IJK form usually. Okay, so if they are going to be in this form, you'll just produce it in the given one, right? Not a big deal, but this is the way we do it. So if the vectors are, it's always the case, but it's not. Okay, now what we need is, we did the dot product. You see the difficulty with the dot product is a very nice one. But the difficulty for our purposes is the fact that the dot product is not a vector. You see, dot product is a number. When you find it, it's a -4. Because you multiply these scalars. So what we need is going to be the fact that we need to be able to use a kind of a product that would create a vector for us, okay? So that's why we have to bring something else to be able to get that vector. This is one reason. The other very important reason is, in many problems in this course, when we go on, and in application in science. In application in science, you are always be in the need of finding one vector which is going to be perpendicular to other two vectors. You see, two vectors would be given to you. Then they ask you to find a vector that's going to be perpendicular to both those vectors. In order to find it, so you need the new product, if you like, that we call it cross product. Okay, so it would be very important for us to get this one. So that's why we are going to introduce 11.4 dot product. At the end of the course, there are a couple of, we have two famous theorems that we are going to have. We call it the Stokes theorem, Green's theorems, especially in case of the Stokes theorem. We are going to use all these type of ideas that we are going to have in this section. Okay, so that's why we need it. So 11.4. As I told you, they are all going to be used as a domain of whatever we are going to do in future. So what's a cross product? Okay, cross product. We already talk about the dot product, so that's going to be cross product. Cross product of two vectors. Okay, again, I emphasize the dot product is a number and you need a vector. So that's one. Again, I emphasize that the reason that we need this one for future is the following. In many, if you like, many applications of this course, applications of vectors in science or in this course, we are going to be needed. So one V or one needs to find a vector that's going to be perpendicular to the two given one. Find a vector that is orthogonal or perpendicular to the two given vectors. Given vectors. Okay, so we have the vector A and the B. So we want to find the vector C that's going to be perpendicular to the A and perpendicular to the B. That's the need. The cross product is the answer of these problems. So as soon as two vectors are given, you find the A cross B. A cross B is going to be a vector that's going to be perpendicular to the A and the perpendicular to the B. So the cross product, okay, the cross product of the given vector, cross product of the given vectors is going to be the answer. Given vectors is our solution, this solution. That's the main application of the cross product. There are some other geometrical applications that we are not going to be interested in. Okay, now, in order to get the cross product, we can simplify the things if we use the notion of a matrix. Okay, that makes things easier for us. So we are going to be interested in the not match operation with the matrices. So we're going to be interested in the determinant of a matrix. You may have probably heard about this one if you've done linear algebra or just college algebra. So what I'm going to do really, we assume that you don't know anything. So briefly, we just give you the one that we need in case you need it to be refreshed, okay? So that's why we are going to review the notion of the determinant. If you know it in advance, that's fine. But again, as much as we need only, okay? You don't need the linear algebra for this one. It would be nice if you know it, okay? So before getting to this definition, I have to do that review to make sure that you are ready for it. So the reviewing is going to be the following. I just review the notion of a determinant of a matrix. We need only determinant of the matrix of a 3x3 only, nothing else. Okay, so if you know it, if you have done linear algebra, you are fine, but otherwise, we just talk about it. So we start with the matrix of a 2x2 matrix. Suppose A is equal to, we don't need the 2x2 directly, but so if this is going to be 2 by 2 matrix, means 2 rows, 2 columns. Matrix. Then the determinant. Determinant is a number, is a numerical function if you like. Then the determinant. Determinant of A is going to be denoted by, is the depth of A, one notation. The other one is like the absolute value type. We use both of them. Okay, and is going to be defined by, it's just a number. That's it. The determinant of the A. If you want to write in matrix form, you have to get the right, a straight line, if you like, the vertical line. It's going to be A, B, C, D. You kind of cross multiply. A times D, AD minus BC. So that would be the determinant of a 2 by 2 matrix. Okay. So for example, if the matrix A is 2, 5, 3, -1, then the determinant of A, the depth of A is going to be equal to cross multiply. It's going to be 2 times -1 minus 5 times 3. So it's going to be -2 minus 15, which is -70. So the determinant of A is equal to the -17. And then with that. Okay, so this is going to be for 2 by 2 1. That is going to be the case. Determinant is just this, the one that I'm explaining here. And determinant is going to be a function. So if a matrix is given to you, you see if the matrix A is given to you, determinant of the A is going to be a function that's defined by this formula. That's for the 2 by 2 matrix. Okay, then you can define it by the 3 by 3 or etc. So that's a notion of the determinant. Okay, any question? It's going to be quite a lot, in linear algebra. We consider as a function and we talk about it. But for the time being, it's just a machine. Okay, is that a machine that we're going to use to be able to write the formulas in a nice form, if you like. Okay, any question? So this is how you do it, the determinant of the A for the 2 by 2 matrix that you're going to have. But we need a 3 by 3. So we're going to extend it for the 3 by 3. So let's have a 3 by 3 one. So again, in brief form. So if A is going to be a 3 by 3 matrix. 3 by 3 matrix, just the way we write it down. You need 3 rows, 3 columns. And this is the way we identified the terms in linear algebra. So the first term over here, we call it A11, means the first term, first column. Then we have A12, first row, second column. A13, the first row, third column. Then we go with the second row. A21, second row, first column. A22, and the A23. Okay, for the third one, A31, A32, and the A33. It's the way we identify it, It doesn't matter if you don't like this notation, you can call it anything else you like. because you are going to define the vectors in three-dimensional. So in three-dimensional, this is what you need. Okay, so if this is going to be is a 3x3 matrix, if this is going to be the case, now how are we going to define the determinant of this one? The way we're going to define it, we reduce this 3x3 into the 2x2. And we already got to talk about the 2x2. Okay, if this is going to be the case, then this is how we find the determinant of the A. Again, there are many possibilities, shortcut, but it's just one shot, really, one case. So we stay with one method only. If you have the, if you know more, it's okay, you can use it. But the way I'm going to use it is going to be just very standard one. So the way we do it, we reduce this one into 2x2. This is the way we do it. We start with this first row. You see, consider the first row here. So we're going to get the first term here. It's going to be A11. Then we multiply by this matrix, you see. We are going to eliminate the first row and the first column. If you eliminate the first row and the first column, the result is this matrix, 2x2. We find the determinant of this. So it's going to be times the leftover matrix. And this is going to be A22, A23, A32, and the A33. And we already got the formula for this one, and we can do it. Remember, you cross multiply and you get these numbers. Okay. Then we continue in this first row. We go to the second one, A12, but use a negative sign, minus A12. Again, we multiply by we reduce the matrix by, you're eliminating the first row and the second column this time. The leftover matrix is going to be this one. So it's going to be A21, A23, and this is going to be A31, A33. That would be the second part. Okay, it's A12, you eliminate the first row, the second column, and the leftover. We don't usually write it down, we just get the numbers because the determinant again is going to be cross multiply to get these numbers. Okay, and finally we go to the last one. So it's a positive, negative, positive, less. The last entry is 13, A13. Now you are going to eliminate the first row and the third column. So the leftover is going to be this matrix. The leftover is going to be A21, A22, A31, and the A32. You find this one and then you're done. Okay, I can write the formula all together, but you don't have to memorize that formula really. So it's just one case, you write it down, and then you're done. Okay. So I'll just give you one example to see how I'm going to do it. Any question? Again, you can use your calculator to find it, of course. Why do we add A3 instead of subtracting this one? No, you see the formula for these ideas are going to be positive, negative, positive. In general, in linear algebra, the way we do it, these coefficients are going to be this one. You see, we call it a -1 to the I plus a j. Then this is going to be the AI and the j. You see, in the first case, you get the A11. So I is equal to the 1 and j is equal to 1. So that gives me -1 squared, which is positive. In the second case, you see, in the second case, I is 1, j is 2. So 1 and 2 would be 3, negative 1 cube would be negative. In the third case, I is 1 and 3. 1 and 3 would be 4. So that's why you get a positive. Okay? We call them cofactors in the linear algebra. So this is the way I did it. I just used the Ci and the J can be 1, 2, 3. So that's going to be the one that you have, negative 1 to the I plus J. And the job would be Aij. Okay? But things, we don't need quite a lot. So we just stop with this type of, we be fine to get this one through. Okay, so you should be able to evaluate it. Let's give one example. Any question? So we need a 3 by 3 matrix to find the determinant of this, okay? And we put them together. It's easy, you just get you can do this one in any row you like. Okay, in any row you like, but since it's going to be just one, so we're not going to bothering to get into the details of that part. Okay. Yes. If you use a straight line, we mean it's determinant. Yes. A straight line means determinant. Instead of writing the determinant, we just use this. Yeah, that's going to be the case. Okay. So let's get one example to get to read. Then you are going to do it when you want to find the cross product. So it's going to be used for some three important concepts in the case of the integration. So I want to make sure we know it. So let's start with this example. Again, if you have a calculator on TI, give you the result right away. And you can use it on the test, but we can find it as well. So there you are. Let's do this one. If A is equal to, that's the matrix that we're going to have. The matrix is 2, negative 1, 3. And the next one is going to be 4, negative 5, 1. And this is a negative 2, 0, and 5. Okay, this is the case. Then we want to find, okay, then find the determinant of A. Okay, let's do it. Set solution. Start with the first row and distribute it. That of A is equal to 2 times determinant of, you see, eliminate the first row, first column. So the resultant matrix is a negative 5, 1, 0, 5. Then you come back and you find the determinant. Okay, that's the first part. Minus the second entry is a negative 1, negative 1. Matrix, you eliminate the first row, the second column. So the result 4, 1, negative 2. Okay, 4, 1, negative 2, 5. That's the second part. Remember, plus, it's alternatively positive, negative, plus the term is 3 here. You eliminate the first row, the last column. So we get 4, negative 5, negative 2, 0. So that would be 4, negative 5, negative 2, and 0. That's your formula. And we do these, quickly when we don't write it down. Now get those determinant is going to be 2 times determinant of a matrix. Remember, you multiply these two together. Negative 5 times 5 would be negative 25. Minus, you multiply these two together. 0 times 1. 0 times 1 would be 0. That's the first one. Cross multiply to get this. Next one, a negative would be positive. So we won't get anything, it's just 1. Cross multiply 4 times 5, 20. 4 times 5, 20 minus negative 2 times 1, which is a negative 2. Okay, so it's going to be -2, but I write it down so that you know what's going on. Okay, that's the case. Now +3. Same thing. 4 times 0 would be 0. Minus -2 times -5 would be a +10, but there's a negative here. That's it. So this is going to be 2 times -26. Okay, and this is going to be negative positive +22. And that gives you -30. So that give you -25. I'm sorry, I made a mistake here, yes. -5 times 5, -25, 0 times 1 would be 0. So -0 here, sorry. See, 0 times 1, 0. So I get only -25 here. That's a -25. Okay, so what I have a -50, a +22, +22, and a -30. So that give me -80 plus 22. So my determinant is going to be -58. That gives you the final answer. Okay, so this is how we're going to find the determinant of a 3x3 matrix. And in practice, really we do it quickly, and you don't have even to write this. You can get the numbers right away. I can give you another one, just find it quickly so that you know how we do it. Okay, so I do another one in the quick form, but you're fine to do it whatever method you like or feel comfortable. Okay, so let's get this one. Is a -1, 5, 2, and this is going to be 0 to -1, and you have the 4, -3, 0. So find delta B. Okay, I do it in the short form. You can do any row if you like, If you are going to be in linear algebra, you use the second row. It's not a big deal in this case, of course. You can do the row. See, this is the way we do it quickly. So I want to find the determinant of the B. The first number is going to be -1 times it by, you see the matrix. You eliminate the first row and the first column, so the matrix is this one. 2, -1, -3, 0. Cross multiply. 2 times 0 is 0. Minus -1 times a -3 would be +3. But there is a negative here. So that gave me the first one. Okay, the next one, minus. The entry is 5. I eliminate the first row, second column, so the matrix is 0, -1, 4, 0. Cross multiply. 0 times 0 is 0. Minus -1 times 4, -4. But there is a negative sign here, a +4. Okay, plus the last one is 2. Eliminate the first row, the last column, matrix, 0, 2, 4, -3. Multiply. 0 times -3 would be 0. Minus 2 times 4, 8. So that's it. It's a -1 times a -3 is a -1 times a -3 minus 5 times 4 and the 2 times -8. So that gives you 3 minus 20 minus 16. 36, 33. -33 is going to be the final answer. So, some people, they write it down in this form and we accept it. So, not a big deal. You get it and you can check it with your calculator. Any question? So, and that's almost the review that we need. I give you your break. We come back and we do it. We are ready to give you the definition of a cross product. The cross product would be the determinant of a specific matrix. The first part, the matrix is going to be I, J, K. You write the first vector here and the second vector here, and you find the determinant. That determinant would be a vector. That result is going to be the cross product. And we know we do it right away. No. For the exam, I told you, I'm not going to give you the formula sheet myself. You can bring yourself. You can write the formula, on one page, two-sided. This is one page, two-sided. Write every formula you like, just formulas. This is we call it the formula sheet for the exams and the final. You can take this one with yourself to the, when you go to the center for taking the test, or the test 1, 2, 3, and the final. The instruction is already given to these centers. They know it. So write it down. Yes, you can do whatever you like with the formulas. You label it, because you are going to use it. So just write it down the way you like it. So it's a one page, two-sided for each test and the final. You don't have to memorize the formula. Let's have a break. It's something like 10 minutes, 12 minutes. It's at 12:07. Then we come back and we give you the definition of a cross product. See you then. Any question? What's the question? Okay. Okay. So we are going to continue to get that definition. So we talk about determinant. Okay, this is a tool that we're going to use. Now, if you are going to be serious about working with the determinant, this is a 3x3. You can do it for, n by n. So there are some ways that we can simplify these operations. But for this course, there is only 2 cases that we're going to use. So I'm going to make a remark over here before getting to the definition that we have. One of them is that it's clear that you see if you form the matrix over here, if one of these rows, all the terms happen to be 0. So if you get the 0, 0, 0, 0 over here, of course, when you find the determinant would be 0. Okay, so that would be useful for us because when we use the cross product, we want to know what would happen if you multiply by a 0 vector. And the other one is that we are going to use is sometimes if you switch the rows, you see if this is the given one, and if you change this matrix by switching the first row and the second row, the determinant of a matrix, the resultant matrix, is going to be opposite of this one. You see, this is a negative 33. Then the determinant of this new matrix would be a positive 33. So we need these 2 because we are going to talk about the community, the properties of these cross multiplication of the products. So I'm going to make a remark of this fact so that when we are going to be when we want to use it, so we have some idea of the origin of the argument. Okay, so let's make this one as well as a note, and then we get back to our business. So the first thing that we're going to use is this one. Okay, so this is if the one that we need is this two. If 2 rows are going to be the same, if 2 rows in the matrix, if you like, matrix A are going to be the same entry, then the determinant of the matrix is 0. It's easy because you subtract one row from the other one and you end up with the row that contains all zeros. That would be useful for us if you want to multiply a vector by itself. And the second one that we are going to use, there are a list of these, but we are not going to use it. The second one, if you interchange the rows, so if B is going to be a matrix, is going to be a matrix obtained by interchanging or switching by interchanging 2 rows of a matrix A, of the matrix A, then the determinant of the B, the new matrix, is equal to the negative determinant of the A. Okay, so this means in the case of the cross product, if you switch it, interchange it, the result is going to be the same of the original one. Okay, so you will see when I'm going to use it. So just give it a hint, then we are going to use it in the definitions. Okay, now we are going to be ready to give you the definition of a cross product. Any question? So there are quite a lot to talk about the determinant, but we don't need it. So let's get back to our business. So this is, now we are ready to give you what is the definition of a cross product. 2 vectors would be given, and you want to find the cross product. So if A equal to the first vector A1, A2, A3, and the second one B equal to B1, B2, B3 are vectors. Okay, are two given vectors. Okay, two given vectors in R3, three-dimensional. Then the cross product. Then the cross product. Okay, cross product of A and B is denoted notation is going to be denoted by, this is the notation, A cross B. A cross B. And is defined by, that's it, A cross B is defined by the determinant of this matrix. Remember, a straight line means determinant. The first row you have I, J, K. Then the second row would be A, component of the A, A1, A2, A3. And the last row would be B1, B2, B3. That's it. And you know that you can find it. My suggestion is to write this one and then evaluate it. Some people like to memorize formulas. If you want to memorize the formula, you have to open up this one. Say, just do it, in case you want it, but I prefer just to find it. If you want to find it, as we talk about it, you have to distribute it. The first row would be I, so we get the I times the determinant of the resulted matrix. Remember, you cross these two out. So that give me A2, A2, A3, B2, B3, B2, B3, minus the second entry is J, again matrix. You remove the first row and second column, the matrix A1, A3, B1, B3, A1, A3, B1, B3, plus K. Matrix. You remove the first row, the last column, A1, A2, A1, A2, B1, B2. Okay, I just distribute the matrix that we have over here. Then you can go on and distribute this. So that would be the formula A cross B equal to, you cross multiply to get your matrix is going to be A2 B3 minus A3 B2 times I. The next one minus, you do this one, A1 B3 minus A3 B1 J. And the last one plus A1 B2 minus A2 B1 K. See, some people like to memorize the formula. That's going to be one, but you don't need it really. You just go stay with the matrix and you'll be able to find it yourself. And it's not easy it's not difficult to memorize. Even this one, I is, the position of the I is the X coordinate, if you like. So the first one, so then it's going to be 2, 3, 3, 2. Then we get the G, you drop the 2, it's going to be 1, 3, 3, 1. We get to the K is going to be 3, so that gives 1, 2, 2, 1. It's not a big deal. I prefer just to find it every time that I want to evaluate it. But it's up to you. You can use either one to be able to do it. Okay. IJK all 1. No. No, IJK is just IJK. Okay. Because the result is a vector. They are not one. IJK. You see, IJK is going to be on the first row. On the first row, you put the IJK. On the second row, you use the first vector, and then use the third vector. Okay. It's going to be a vector. So at the end, you have to have those numbers. Okay, so I just emphasize this. In fact, note that that's a big difference between whatever we did so far. Note that A cross B is a vector. Is a vector in R3 all the time. So your final answer must be in terms of the IJK. Okay, your job is to find it. We give you 2 vectors, and you write this formula and quickly find it for us. Okay, any question? So we need to determine only by or get this definition really. Okay, so let's get one example. It's going to be used in future quite a lot, and anytime we use it, we just we just use it to evaluate the vectors. So in cross product multiplication commutative, no, wait, I give you all the properties. Not commutative, because you know that if commutative means you switch 2 rows of a matrix. If you switch 2 rows of a matrix, your determinant would be opposite of the given one. So this is another. Let's get this example first, and I give you all the properties. Okay, so this is going to be the case. So basically, that's a standard problem that we have. 2 vectors would be given. We give one of them in this first quiz. Suppose A is equal to, there are a number of the quantities in physics that we have to relate it when we get to the end of the course. And we use this cross product over there. Okay, suppose this is given to you and we wanted to find the following. We wanted to find the A cross B, B cross A, and A cross A for some purposes. You see, this is when you switch the row. This is when 2 rows are the same. So automatically this would be 0. And if you get the first one, see, if you get the first one, you multiply by a negative sign, we get the second one. This is why I gave you this. But let's check it. That's it. Go with the first one. A cross B is equal to the formula determinant IJK on the first row, A component of the A, 1, 2, -2. B, remember the order is important. 3, 0, 1. That's it. Find the determinant. Equal to, remember, I times, delete the first row, first column, matrix, 2, -2, 0, 1. Find the determinant, 2 times 1, 2, minus -2 times 0, which is 0. That's the I part. Remember, the second one is negative, minus J. Eliminate the first row, second column, matrix, 1, -2, 3, 1. Find the determinant, 1 times 1, 1, minus negative 2 times 3. Negative 2 times 3 would be negative 6. But there is a negative sign here, so make it to the positive 6. Remember, the formula is AB minus BC. Okay, I repeat it again. That was a J out matrix 1, negative 2, 3, 1, 1 times 1, 1, minus negative 2, minus negative 6, which is a positive 6. You continue plus K times, eliminate the first row, the last column, matrix 1, 2, 3, 0. Determinant 1 times 0, 0, minus 2 times 3, 6. That's it. Simplify it. A cross B is equal to, is going to be equal to the 2i. Okay, 2i, and this is going to be 7 minus 7j. 7j minus 6k. This is going to be A cross B. Any question? So this is the way we are going to find it. Okay, now you want to find the B cross A. We already talked about it. B cross A means you switch two rows. If you switch two rows, this would be opposite of the other one, minus A cross B. Because we talk about it, the determinant of a matrix. If you interchange two rows of a matrix, the determinant of the result is the opposite of the other one. So this is simply would be negative 2i, negative, negative, positive, plus 7j, negative, negative, positive, plus 6k. So that would be B cross A. Any question? Because you already got the A cross B, so that's why we do it. A cross A. You see, you get a matrix with two rows equal to each other. If two rows are equal to the other, the cross product is always 0. So A cross A is 0, and you don't have to find it. Any question? So this is the way you are going to operate with the cross product. So I'm going to list all the properties that we have, so that you can use it without any proof. Is a new operation. So it's a multiplication. So you are going to check to see if it's going to be commutative, associative, okay, distributive, this type of idea that we are going to have the case. Yes, it's a formula sheet. You can have anything you like on your formula sheet that are going to bring. Okay, so let's check it. There are two types of operations that we're going to have. One of them is going to be algebra. We use a couple of them, but we have to list it so that in case in future you get these type of properties that you are going to be, familiar with. So we are going to call this one algebraic property. There are two types of properties. There are some geometry that we are going to be very much interested on that, but we are going to give you this one too. So what's going to be, okay, what's going to be some properties? We call it the algebraic property. Okay, that's it. Algebraic property of okay, algebraic properties of the cross product. This means just the operations. Most of them are obvious, but we make a note. So if I use something like U, V, W, I mean vectors. Okay, are vectors in R3. And as usual, if I use alpha, beta, if I use alpha, and alpha is a number, is a scalar, then you are going to have the following. Okay. Then we can have the following properties. Let's see. The first one is the one that we already talked about it. It's not commutative, U cross V. If you switch it, it's going to be negative V cross U. The reason is this is a determinant. You interchange two rows, so we get the opposite answer. So that's the first one. Second one, if you multiply U cross U, we talk about it is 0. Because you get this we get two rows with the same entries. So in that case, the determinant would be 0. The third one, the distribution law is going to be okay. So U cross V plus W, you can distribute it. U cross V plus U cross W. That would be fine, easy to prove. And you can do it the other way around. So if you have a V plus W cross U, be careful, it's going to be V cross U plus W cross U. We need these because we are going to talk about when we talk about differentiation, for example, you are going to have product rule for the functions, okay, the vector valued function. So in that case, it depends what type of product you use. If you use cross product, so you are going to use the product rule for the differentiation. So these are where you are going to use it in future. Okay, and if you get the number, the first one is clear. If you get something like, okay, alpha U cross V, it's a number, you can pull it out, alpha U cross V. Okay. What else can we do? That's a 5. Number 6. Number 6 is clear, U cross 0. So you want to find the determinant of a matrix in which one row is all 0. So the result would be 0. What's the difference between the 3 and 4? We just show you that the direction is important. You get the multiplication, you multiply it from the left here and from the right. You see, it's a multiplication over the addition, and this is addition over the multiplications. That's a difference. And remember, they are not commutative. So that's why we have explained both of them. You see, U cross V and the V cross U are going to be the same. So we just want to emphasize that we can do it from two different directions. So that's 5, 6. The only thing that you can't have it is associative property. Okay, remember the associative property doesn't make sense. That is going to be the case. Of course not. Of course not. You just keep asking about the formula sheet. The formula sheet is just the formula. They are going to return it to me. You cannot put any other things. Examples, instruction, no, just the formula. Okay, and the only thing that we cannot have is associative property. So U cross V cross W in general is not equal to U cross V cross W. Remember, we didn't have it for the dot product as well. In the case of the dot product, the difficulty was the concept, but you see, these are all vectors. But in general, they are not equal to each other. So this is the only one that you don't have it. Okay, so it's behaved nicely. The only difficulty is the first one. The dot product is commutative, but this one is not. So be careful about this part, and associative property is not going to be satisfied. Any question? There are, for the IJK, sometimes we have some easy way or shortcut to do it. That's going to be one. Oh, I didn't 6. I'm sorry. You are right. U cross 0 is 0. Thank you. That's one. Okay, thanks. That is going to be the case. Okay, any question? Now, when it's IJK, there's a short form. From time to time, you may use it, not only in this course, but also in the application in science. So I give you that one too to finish it. Okay, so be aware of this is it. You see, this is the one that you're going to use in future. U cross U is equal to 0, and make sure to remember that you cannot interchange it. Okay, in the IJK, there is a short form for these identities. And then we get to the geometry part here. Remember, we were interested in the vector that's going to be perpendicular to the other ones. We haven't talked about that one yet, but this would be useful. Look at this. If you want to do the dots cross product with the IJK, look at this. Suppose you're moving in this direction. This is I, this is J, and this is K. You see, suppose you're moving in this direction. For the cross product, the following are going to be true. Look at this. If you want to find the I cross J, you see I cross J, that give you K. You can use it anytime you like. If you don't believe it, you can check it. And then it's going to be the same. J cross K. J cross K would be I. Okay, and K cross I would be J. Okay, that will be useful from time to time to know it. But you know that I cross I. What's I cross I? I cross I, yes, is 0. Remember? Because it's the determinant and you get 2 rows the same, so it's going to be 0. So J cross J is 0. K cross K is going to be 0. Okay, these are going to be the, the case that, you can use to get these formulas. It would be fun, and we are not going to do it, but it would be fun, right, sometimes to do this type of operations because you have a couple of them in your book as your assignment. I just wanted to see it. So for example, if you want to simplify this expression, okay, I cross K, this is going to be the case. So let's say I'm going to find this one. It's going to be equal to, we get I cross, what is I cross K? You see I cross K. The suggestion is going to be not J. You see, you have to consider the direction that you have. You see, the direction that you get for this one in this direction. So you have I cross K. You see, I cross K, you want to come back. So it's going to be negative J. Negative J. Okay, because K times, you see, if you go in this direction, K times I would be J. So you have I times K. So the direction is different. So that give you yes, it give you a negative J. So then, you put out that negative sign. So that give you negative I cross J. Now what's going to be I cross J? And the I cross J is just K. So the result would be negative K. You see, so I cross K is going to be negative K. Okay, any question? I just want to show you that Yeah. Yes, question. So let's see what is going to be this one. I just want to show that the associative property is not going to be satisfying. Look at this one. This is going to be I cross I, then cross K. Let's say bet. You know that I cross I is going to be equal to the 0. So that gives 0 times K, which is 0. So what's the conclusion? The conclusion is that it's not associative. It's not the same as I cross I cross K. So the cross product, the cross product is not associative. It's not associative. So in both cases, in the case of the dot product and the cross product, you're not going to get the associative property in general, especially for this one. Okay, so this is algebraic property of these operations. Okay, as I told you, there is going to be only a couple of cases that we're going to use, but we just propose it here to keep it for future. Okay, any question? Now let's go back to the what we started with. Remember, what we started with was we say that if you give us two vectors, A and B, we can provide the third vector, which is going to be perpendicular to the given one. So the answer is the cross product. So we're going to show you. So this part is important to know. And there are a couple of problems that there are several problems really to get through this. So the algebraic one was done. What's going to be geometry? Geometric properties. Geometric properties of the cross product. This is the one that we're going to use. Okay, you get two problems on this one. Make sure you pay attention to this. Now, what's going to be this? The first one. Okay, you be question on all of them. The first one is the one that we talk about it. If A and B, if A and B are vectors in R3, then look at this one. A dot A cross B is equal to the 0, and B dot A cross B is equal to the 0. What does it mean? The first one means the cross product is perpendicular to the A. The second one means the cross product is perpendicular to the B. So A cross B is perpendicular to the A and is perpendicular to the B. And that was our target to finding. So this means, so A cross B. Okay, A cross B is going to be perpendicular or orthogonal. Okay, orthogonal to the vectors A and B. Very important fact that we're going to use it. The proof is very easy. You have to just rewrite it really to get this one through. I just show you one of them to see how easy it is, but you have to remember this one. So if two vectors are given to you, and you are going to be interested in the third one, that's going to be perpendicular to the both given one, cross product is your answer. Just for your information, the proof. Easy proof, and that's it. What is the A cross B? You see, note that A cross B. Just determinant. I just write it down in this form. Remember, it was 2, 3, 3, 2, I minus. For the J, it's going to be 1, 3, A1, 1, 3, 3, 1, J. For the K, is going to be, okay, it's going to be 1, 2. It's going to be 1, 2, 2, 1. Okay, that's easy to remember. Remember, I is in the first position, if you like. So the other two is going to be 2, 3, 3, 2. J is in the second position. Is going to be, the leftover is going to be 1, 3, 3, 1. And this is on the third, so it's going to be 1, 2, 2, 1. And you already got the formulas. Okay, now there you are. What is A? A is A1I plus A2J plus A3K. All put together, cross product. What's going to be the cross product? Sorry, dot product. A dot A cross B. Remember, it's going to be A1 times A2 B3 minus A3 B2 plus A2 times this one. There is a negative sign here, so that make it to the negative. And that would be A1 B3 minus A3 B1. And the A3 times A1 B2 minus A2 B1. If you multiply them together, everything will be canceled out. And that gives you 0 right away. You see, I show you how they are going to be canceled out. See A1, B, A1, A2, B3, A1, A2, B3. There is a negative sign here, so this two would cancel out. Next. So that was the first one. The next one is this one, A1, A3, B2. A1, A3, B2. With this one would cancel out. And these last two would also cancel out. So that gives you 0. So A dot A cross B would be 0. Okay, similarly, the same thing. B dot A cross B is 0. So that's it. So A cross B is perpendicular to the A, and the A cross B is going to be perpendicular to the B. And you're done. See, very nice, a nice result. Of course, we are going to use it. We don't need proof, but we have to know it. That this is going to be the third vector that we are looking for. Such an important vector. You will see it. How we're going to use it in the, in at least 3 parts of the course when we get to chapter 14 and 15. Okay, so that's the first property of the of the cross product. If you have, if you find it again. Yes, the second term is subtraction. Yes, that's a subtraction because you need this negative sign to be able to do it. Okay, so this is the first one. The second one give you another geometrical property that we needed. So let's get the second one. You see, this second one is an identity in algebra. I mention it because we are going to use it, but it's not our concern. Okay, we have to know it. Okay, so let's take care of the second one. It's algebra, we call it Lagrange identity. We need it for some other purposes. So if A and B are non-zero vector, non-zero vectors in R3, then you have this identity. Remember, A cross B was a vector. If you find the norm of this vector, norm squared, it's going to be equal to this one. Norm of the A squared, norm of the B squared, minus A dot B squared. It's algebra. I'm going to use it once just to show you a great result that we needed. So we don't need to prove it. We just know it just for a few seconds to be able to do the job. But if you like, this is called the Lagrange. Okay, French mathematician. Lagrange identity. We like it because it gives you a relationship between the dot product and the cross product. Okay, so that would be our second property. I'm not going to prove this one. We don't need to prove it. And also the proof is easy, but we need the next one. One problem would be given to you on this one. Number 3. What's number 3? Remember the angle between the two vectors, cosine of the data is equal to the x dot y over norm x norm y. We're going to find a similar one for the cross product. And this formula is interesting. If data is the angle between vectors A and B, then you are going to have this nice formula. Then norm of A cross B is equal to norm of A times the norm of B times the sine of the data. That's the sine. Remember, the data is angle between. This is a nice formula, and that gives us the second geometric property of a cross product that we're going to have. Okay, you have to know this one. You write down as a part of your formula, but I'm going to prove it for you. We're not going to ask you to prove, but it's nice to see it. How we're going to prove this one is all algebra. So how we're going to do it, I'm going to just use this one. You see, that's it. Lagrange identity. I start with this one, norm square. I have A dot B. Remember, I have the formula for the angle between two vectors. Cosine of the data is A dot B over norm A, norm B. I use that formula, I bring it here, and then that cosine would be changed to the sine. Okay, so the proof is easy. So let's prove it. It's not bad to see. The proof, I need this formula. Recall that. You have to bring the data. We bring it from here. Cosine of the data is A dot B divided by the norm of the A times the norm of the B. Cross multiply to get A dot B because you need A dot B. So A dot B is equal to the norm of the A times the norm of the B times cosine of the data. You see? take this one into the Lagrange inequality. You see Lagrange? So this is the Lagrange inequality that we have. So what we're going to do, we are going to put A dot B here. So this is going to be the next step. Say, okay, I start with the A cross B whole square norm is equal to, by Lagrange inequality, is equal to the norm of the A squared, norm of the B squared, minus A dot B whole square. Substitute is equal to norm of the A squared, norm of the B squared, minus a square, norm of A squared, norm of B squared, cosine square of the data. Okay, I square everything. Remember what you want. You want this one. So what can you do? Algebra. Common factor. Take this one out as a common factor. So what's going to be the leftover? Norm of A squared, norm of B squared. If you put it out, 1 minus cosine square of the data. But you know that the cosine square of the data is what? Is sine squared. So this would be sine square of the data. So what we have? We have that the norm of the A cross B all squared is equal to the norm of the A squared, norm of the B squared, times the sine square of the data. That's it. Take the square root. If you take the square root of both sides, okay, and taking the square, so that give you what? That give you norm of the A cross B. They are all positive numbers, so nothing to worry about. It's going to be norm of the A, norm of the B, and this is going to be the sine of the data. Okay, you may say that the radical sine squared, how do you know that it's going to be sine, not negative sine? Remember, data is between 0 and pi. So the data is going to be between 0 and 180, and the sign is always positive. So everything is positive, and I did prove the formula for you. That norm of the A cross B, okay, norm of the A cross B is equal to the norm of the A times norm of the B times sine of the data. Okay, any question? So the question is going to be from geometry point of view, what does it mean really? And why we are interested in this formula. You see, we are going to be interested in this formula because this is going to be, okay, we can relate it to the, look at this. Suppose you have these two vectors, A and the B, that is already given to you. Okay, this is going to be the one. Suppose this is the A. Okay, and this is going to be the B. Okay, this is the vector A and the vector B. So this portion over here is going to be the norm of the A. And this is going to be the norm of the B. So if you make a parallelogram here, if this is going to be a parallelogram, and the angle between these two are going to be your data, this is the one that we have. Okay, let's see what is this formula is going to be all about. So if you consider the height of the parallelogram to be equal to the h, so what's going to be the area of this parallelogram? You see, the area of a parallelogram is what? The area is going to be A is equal to Remember, the area of the parallelogram is going to be the base times the height. Okay. And so what is going to be the base? The base over here is going to be norm of the A. Okay, that's going to be norm of the A. And the height is going to be H, for example. That's H. That's H. So what else can we do? What is going to be H over here? You see in this right triangle, H is what? H is the opposite side. When it's opposite side, if you want to find it, you can use the sign. Okay, so but what is going to be the sign of the data? The sign of the data is going to be the opposite side, which is H, divided by the hypotenuse, which is the norm of the B. If you cross multiply it, H would be norm of the B times what? Times the sign of the data. If you satisfy here and substitute here, A would be, if you put it here, so we get the norm of the A, norm of the B, sign of the data. Nice. But what is this? This is the norm of the A cross B. So we get very interesting results, and you're going to use it quite a lot, or at least once on your next quiz. That's a conclusion of this argument that we did have, and that's why we go through all this to get to this one. So what is this? So this means if you have a cross product, A cross B, the norm of the A cross B is going to be the area of a parallelogram, area of the parallelogram that has this A and the B, okay, A and the B, as is adjacent sides, if you like. If you want to find the area of that one, that area would be norm of the A cross B. So I'm going to make it official to give you this. Any question? Again, the final answer is the one we are going to be interested, but it's interesting. Let's just go through the proof so that you can see the connection that give you for a while, okay, a good idea. But this is the final part that we are going to use. And that make us, you'll see then in minutes, that give you one problem that will tell us everything we talk about it so far, and we'll be very much satisfied if you can do that problem for us. So the conclusion is going to be, okay, I just have to put this one somewhere to be able to give you that example. Okay, so let me just go to the next page to explain these formulas. So the conclusion of this argument that we did so far is going to be this one. So we say that, note that, okay, note that the area of the parallelogram that has A and B, that has the A and B as adjacent size is, that's it, is A equal to norm of the A cross B. And that would be very important for you. You can use it in order to find it. Okay, any question? So that would be useful. So this is going to be the case that we're going to have. So you must have these to be adjacent side to be able to find it. If this is going to be the case, then the area is going to be. How about a triangle? Also, the area of the triangle that has A and B as adjacent sides is. Any suggestion? For this one? Yes, Daniel, you're right. Danny, you're right. 1/2. You see that the triangle is going to be 1/2 of a parallelogram. So in that case, this is going to be 1/2 of A cross B. You see, because this is going to be your, if this is going to be a triangle that you have, okay, then you can think about it. You can make it as a parallelogram. So it's going to be 1/2. You see, it's going to be 1/2 of that parallelogram that you have. So you have to be aware of both of them and to be able to find it for us. Okay, so we are going to be in a position to give you just one problem of everything we did so far. So this is going to be the one that, so I give you that problem and you will see it in your practice one, practice test, and a couple of them in your book. That it's going to be a nice problem. And we've covered everything we did so far. And that gives you the idea that what we need to know about this practice section. Okay, any question? So you should be able to find A cross B for us. Make sure you know that it's a vector. From geometry point of view, is a vector that's going to be, oh, sorry, this is A and the B. These are A, B. Okay, I repeat it. Is the vector. Okay, you make sure you know that this is a vector that's going to be perpendicular to the other two. Okay, and you can use it for this type of ideas. So I should give you this problem to finish it. Okay, are you ready? That's the main example that we cover. I go to the next page. So you see this problem all over the places because they like it. That's it. Again, we don't need anything else. In future, you are going to use these ideas in several places. And the way you use it is only really just finding it. These are a tool. It's a machine for us. A machine, when we have a complicated formula, we change it to these ideas. So you should be able only to find it for us. So nothing to worry about. But this is it. This is a particular, typical problem. Find the area of the triangle. Of a triangle that is determined determined by the points, by the following points. These points are, the vertices, if you like, of a triangle. P1 equal to 2, 2, 0. P2 equal to -1, 0, 2. And the P3 equal to 0, 4, 3. That's it. You see, this is going to be a triangle that we have. So you want to find the area, solution. You can derive, as you like, but I'm going to identify. You see, suppose this is a P1, and this is going to be the P2, and this is going to be P3. So this is a triangle that you have. And you know the area that we have. We can use that cross product of the vectors, but you need vectors to be able to do it. So if you call this one the vector A, if you like, and if you call this one to be vector B, and then you know that your area is going to be 1/2 of the norm of the A cross B. You see, this is the way we can, we can do it. So the problem is going to be you have to find the A and the B yourself. So A is going to be, the vector A is this vector, P1, P2. Remember the initial point is P1 and the terminal point is P2. In order to get the component form, remember we subtract the P2 minus P1. So this is going to be a vector, -1 minus 2, the coordinate, comma, 0 minus 2, comma, 2 minus 0, 2 minus 0. So that vector would be what? It's a -3, -2, and 2. That's a vector A. Any question? I gave this one several times on the test. Some people, they make a mistake. They just use the P1, P2, P3 as a vector. They are not vectors. They are points. You see, they are points. You have to make these vectors according to the definition that we talk about it. You need those line segment first. Okay, so that's the A. We got the B. B is P1, P3. You can pick any other combination, but you have to be consistent. Again, we have the P1 and the P3, so it's going to be P3 minus P1. So the vector 0 minus 2. Second component 4 minus 2. The third component 3 minus 3. 3 minus 0. Okay, simplify it. So what we have? We have a -2. Okay, -2, +2, and the 3. There you are. You have your vector. So now you have to find the A cross B. Any question? A cross B, determinant of a matrix. Determinant of what? I, J, K. The first vector, -3, -2, 2. The second one, -2, 2, 3. Find the determinant is equal to I times. You eliminate the first row, first column, the matrix, -2, 2, 2, 3. Cross multiply, -2 times 3, -6. Multiply minus -4. Always minus J, second one. Eliminate the first row, second column, the matrix, -3, 2, -2, 3. That give a -9. -9 minus 2 times -2 would be -4, but there is a negative sign here. Make it to the +4. Okay, plus K times. Eliminate the first row, the last column. The matrix, -3, -2, -2, 2. Multiply. -3 times 2, -6. Minus -2 times -2 would be a +4, but it's going to be -4. Okay, so A cross B is equal to what? Is a -10, -10I That gives you -5, +5, +5j. And that gives you -10k, -10k. So that's A cross B. Any question? Now you have to find the norm. A would be 1/2 of the norm. Okay, go for the norm. So the norm of the A cross B is going to be equal to the square root of the component -10 squared, 5 squared, and then -10 squared. 100, 25, and 100. Okay. So that gives you 225, which is 15. So the norm would be 15. So area is going to be what? It's 1/2 of the norm of the A cross B, which is 15/2. So the area of a triangle would be 15/2, and then you that. You see, this is the type of operations that we have. So, so far, just evaluating. And that is going to be the case. Okay. So we're done with the cross product. The other things that you have to know is that the fact that so there is going to be one conclusion of this one. Let me just talk about that one too. Then we're going to be finishing. Okay. Any question? So pay attention to this problem. This problem is going to be used in other version in future. So the beginning is important. The points are given. You see, they are points. They are not vectors. So you have to create the vectors yourself. You create the vectors first, okay? Then you know that as soon as you get the vectors, or the area problem is just a one. This is the main application of this this formula for the time being. Just to finish it, I just give you one more thing about this area that we have. Okay, just I forgot to give you that one. Let's come back here and talk about it. What would happen if A cross B is equal to the 0? What can you tell us about the vectors? You can use this, if you like. A cross B equal to the 0. They are parallel. Excellent. Yes, that's it, Danny. That's good. That's true. You see, if A cross B happen to be equal to the 0, this means in this case, you cannot form this, what's that, this parallelogram that, if you like. So this means A and B are, you know that there are going to be two cases, either are parallel, or if you cannot make this one, they are going to be in the same direction, if you like. So it's not bad, make a, because I'm going to post these notes. So I put it here for you. You are going to use it in a couple of places in future. So let's make a record. If that's it, if A and B, remember A dot B 0, they are perpendicular. And now we get A cross B. If A and B are vectors in R3, then you see A cross B is equal to the 0, if and only if A and B are parallel. A and B are parallel vectors. You know that this means one of them is a scalar multiplier of the other one. A is equal to the K times B for some K, some scalar K. Okay, and the reason is, as we talk about it, you see, remember if you have this parallelogram again, you see A is the area is A cross B. And this would be 0. If you get the 0 means you are not going to have a parallelogram, you see. This is what we're going to have. This is A and this is B. You see, this is A and the B. So in that case, this is the one that we call it the parallel, okay, parallel vectors. And so that would be the cross product. And there is a similar one, we call it a scalar triple products. Okay, that's just one formula. And because we need it for future, I talk about that one too. Then we are done with the 11.4. So we're almost done with 11.4. 11.5 is going to be lines and planes. So we are going to cover that one too, or just some part of it, so that we be able to do your quiz. So our target is to the end of the 11.5 for this week. Okay, so your practice quiz is already there, so we can start working on it. Okay, there are you can do many of those problems, and then we do the 11.5. Then I post your quiz on Friday, and then you can bring it back usually by Monday. But for this one, because the Monday there is Monday is holiday, so we don't have any class. We cannot have class on that day. So that's why we have to finish 11.5. And then you can submit it by Tuesday. Okay, so I do 11.5 tomorrow. So get that practice quiz that I've already posted. I think the solution is also posted for that quiz. I check it. If it's not, I'm going to post it. So as I told you, our target is to be able to quickly finish these sections, because they are preliminaries. In future, they are going to use in some other places that will enable us to get to the function part, which is chapter 12. Okay, so just pay attention to this, just check it. If you have any question, let me know. Otherwise, see you tomorrow. Okay, so the homework, yes, the homework will be due for the quiz. Remember, on the day of the quiz, we collect the assignment. So the assignment number is already posted for you. So start working on those. Okay, that's it. Have a good one and see you tomorrow. Let me know if you need anything. Bye-bye.